Hello, everyone, and welcome to the Harness Edge Computing webinar by DIAWAY, AMD, and Virtuoso. Thank you for joining us today. During the next 45 minutes, we will discuss key topics on business continuity and edge computing, such as how to provide lower latency, better reliability, and quicker time to insights. You will learn about the latest hardware trends from AMD, and we will find out more about DIAWAY's brand new product, the complete server solution called the EDGEBOX. Other important points we will be covering and discussing with you today are: what is DIAWAY EDGEBOX and how it helps make a massive and quick expansion of services across a few or many points of presence, reduce security risks and get higher revenue and performance with AMD EPYC second generation processors. Learn more about Techonomics' proven holistic approach that views IT as the core of any business and guarantees tailored for the task and financially optimized infrastructure design. And you will learn about Virtuoso hybrid infrastructure benefits, Virtuoso's robust HCI solution, available as on-prem HCI platform running on EDGEBOX as end-to-end solution, or as part of Virtuoso hybrid cloud. By the end of this webinar, you will have a clear step-by-step roadmap to roll out turnkey infrastructure fast, prepare for tomorrow, and optimize your TCO. A few words about the webinar organizers. DIAWAY is the big data storage and networking integrator for data-intensive global organizations. The company designs, deploys, and optimizes systems, software, and storage solutions that enable enterprises, cloud providers, and software companies to generate more value from their data. DIAWAY helped leaders like Acronis, Cloud Linux, Rushfiles, Rike, and others to save a lot on proper infrastructure designs. DIAWAY is an official partner of AMD, Western Digital, Juniper, and many other global hardware and software vendors. For this Harness Edge Computing webinar, DIAWAY teamed up with AMD, who are the renowned leaders in server processors for hyper-converged infrastructure and constitute a huge and crucial part of the new product, DIAWAY EDGEBOX. Founded in 1969, a Silicon Valley startup, AMD has grown into a global company of 11,000 people, achieving many important industry firsts along the way. AMD today develops high-performance computing CPUs and virtualization products for desktop, laptops, workstations, servers, consoles, and embedded markets. The company is going through a high growth, and its shares are traded at an all-time high, with valuations going above its primary competitor. Going fabless has helped the company to lead with its time-to-market 7-nanometer-based CPU and GPU, bringing higher performance, computational density, and power savings. Virtuoso is a pioneer in virtualization technology with 20 years of experience in software business. Virtuoso started with system containers and eventually extended the portfolio and solution stack to virtual machine virtualization, software-defined storage, and hyper-converged solution. Presently, Virtuoso is a vital member and #4 contributor to the QEMU KVM community. In the year 2000, Virtuoso breakthrough container technology allowed service providers and hosters to drastically save on infrastructure and increase marginality of services. Virtuoso is bringing hoster and service provider DNA to the enterprise and telecom world, powering over 450 businesses all over the world. Among Virtuoso customers are large and medium service providers such as GoDaddy Group, 1&1 Ionos, Mylock, and GMO in Japan, telecom operators such as America Mobile, Telecom Italia, Telstra, and from the enterprise world, Tata Corporation, and many more businesses powered by Virtuoso MSP partners. Please prepare your questions to win prizes from us today. You can use the Q&A section in your Zoom to submit questions, and top 3 questions are eligible for the wonderful prizes we have today: t-shirts, power banks, and full box of fine Italian wine. And today here with us, we have co-founders of DIAWAY, Alex Ragel and Dmitry Lyautov. Our guest speakers today are Alexey Nichuyadov, Product Marketing Manager at AMD, and Vladimir Porokhov, Product Manager and Product Owner at Virtuoso. So Dima, the topic of our webinar today is harness edge computing. Can you please speak to the relevance of this topic?
Hi, everyone. The answer is not simple. I will explain the perspective in a bit. As I used to begin on past webinars, my favorite topic is money. It still is my favorite topic, but now we go there through data. Industry reports say the data is growing exponentially, and with it, HCI market grows too. The fact is 90% of data we have now has been created in the last couple of years. And now the growing data needs to be processed even more than earlier. That's why HCI market is booming. This is a huge market to address, a huge challenge, and a huge opportunity. The world has never been so connected as it is now. It helps to serve global markets without being physically there. The talk about this opportunity and this challenge is the reason why we are having this session. Ask your questions in the chat and we will address them during Q&A session, and we'll select the most interesting ones after the webinar. What is so challenging with hyperconverged market? The key elements that should be mixed in a modern HCI solution are good scalability, excellent serviceability, and cost efficiency. Not too difficult to make 1 out of 3 requirements. Way more challenging to meet all 3 at once. It becomes even more challenging to combine all these elements with multiple points of presence. To add more challenge is need for secure data storage solutions, as security issues have been headliners for the past years, and it only gets worse. All in all, it means that readiness for the workloads of today and tomorrow dictates a conventional approach. We started working on similar projects 2 years ago, and the challenge from the past slide has become such a pain just now. Part of the problem is that a global expansion is now easier even for non-hyperscalers, but the challenges to solve are the same. We have typically seen the attempts to resolve this puzzle handling all its elements separately. Trying to glue together hardware, software, network, management layer, support, collocation, IP transit, and logistics can easily become a nightmare when it all has to be done by, as an example, software company that only wants to start offering their services in a few or many places worldwide. Seeing these struggles, we decided to design a concept that later became an EDGEBOX. EDGEBOX is a mini data center-like turnkey plug-and-play solution built for service providers, software companies, integrators, and value-added resellers. It is fully integrated, provides for unified management, and really fast to market. On the hardware side of things, EDGEBOX is built with the best components from the best components in their respective industries. AMD is responsible for compute and at a later stage for GPU. Storage part is served by Western Digital and the networking piece by Juniper Networks. EDGEBOX covers the most trending use cases, such as private and public clouds, VPS and web hosting, artificial intelligence, and machine learning infrastructure, Kubernetes, storage as a service, VDI. These use cases are provided with hyperconverged infrastructure that consolidates traditional hardware-based infrastructure, compute, servers, networking, and storage into a virtualized software-defined environment. This simplifies management and reduces operating costs. It also increases efficiency and flexibility because everything is reduced to one integrated solution. DIAWAY EDGEBOX is a concept, not a specific product with fixed specifications. The beauty of its idea is in a few key elements. The solution is complete with hardware, software, networking, and optionally support data center and IP transit. Easy and predictable and cost-effective scale step. The solution is always redundant. The solution is built to work with modern components for crunching data, GPU, and smart NICs. The specifications are fine-tuned for specific software vendor, providing for the best total cost of ownership and the return on investment. It is very convenient framework for software vendors to onboard into and make their software packed for service providers or resellers. For compute, and as I mentioned GPUs later on, the selection of AMD was very natural to us. For those working with vendors closely, it was impossible not to notice advancements made recently, and knowing what's coming, it only made us feel more confident about the choices. This knowledge was applied while creating designs and joint solutions with Virtuoso, and I'm sure it is going to be a success. With that, a word to Alexei from AMD. Alexei?
All right. Yeah, I'm here. Good morning, everyone. My name is Alexei Nechuyarov. I'm responsible for technical marketing at AMD in EMEA region, predominantly Europe and Middle East. So what I'd like to go through today during my next 15 minutes is talking about why EPYC platform is well positioned for HCI and software-defined infrastructure deployments, and also speak about what exactly we're bringing to the table. So with that, let's move forward. Let me see if I can control the presentation. Okay. So AMD, as Tamara has already mentioned, is in the market for the last 51 years, and we've grown into a large platform provider. Increasingly, we're not thinking about just socket level hardware, but rather what kind of solutions we can bring to the market to accelerate data management and get into the insights, to the end results. So we are increasingly working with our partners, both in software and hardware ecosystems, to make sure that there are ready predefined solutions that are simple to deploy and manage. And as Dmitry has already mentioned, let's just take a couple of minutes to go through traditional versus hyper-converged. Traditionally, obviously, we've had to have a lot of different IT personnel to manage silos of hardware, be it networking tier or compute or storage. There were different types of storage, and there are today still. But if we look at what hyper-converged brings us to, is actually the ability to consolidate different tiers, at least compute and storage. And some vendors also provide networking tier combined as a whole holistic solution. And so the idea of taking x86 servers, standard industry servers, and increase your infrastructure, add as you scale your workloads and the amount of data, is really the trend that many organizations really embrace today. So if you think about overall about where AMD is in this equation, really can accelerate the entire HCI deployment and multiply benefits that HCI provides. I'm trying to go through the next slide. It doesn't work though. Dmitry, can you take over because I cannot slide? Okay. Okay, let's see if it works.
Maybe there's a latency.
Okay.
So, do you need my assistance now?
Yeah, please just roll to the next slide, please.
Okay.
So I'm just going to speak about EDGEBOX and why AMD EPYC. In terms of the EDGEBOX, it's a very interesting example of doing everything in one box. It's both. There are signs of appliance approach where you as a customer get a complete solution managed from minimized number of management panels, and also the entire service is provided through one company, through the supplier. So so to speak, you have a single throat to choke, which is crucial in today's fast-changing environment. On the other hand, the EDGEBOX could be configured in a different ways to either do a software-defined storage or a more classic virtualized infrastructure to run VMs. And so it's the best of both worlds, if you ask me. It can scale easily. It's validated. It runs with a predefined set of software, and so the partnership with Virtuoso and other ISVs is quite important here to ensure that you receive the box, and your organizations that you cater to receive a fully fledged box with all functionality inside. EPYC provides a lot of value, so it really is a multiplier what HCI brings. It both provides scalability and higher performance, and we'll delve into that in a sec. And it's also at the same time able to reduce your total cost of ownership as well as your initial acquisition costs. And DIAWAY is going through a couple of slides, I guess, to address specific TCO value that you would obtain with the current iteration of EDGEBOX. And AMD is well known for innovation. We historically deliver on being first to market with various server technologies. We were first to market with things like integrated memory controllers, highly scalable fabric like HYPERTransport. And today, with our second generation EPYC CPUs, we capitalize on using a Zen 2 core microarchitecture, which is really very high performance across various tiers of workloads. It has very high compute density, up to 64 cores. It has the largest amount of level 3 cache per core, up to 16 megabytes of cache per each core, which is unattainable on our competitors' infrastructure today. We were first to market with abundant amount of PCI Express Gen 4 lanes. There's a very fast and scalable memory subsystem to really feed the cores with data. And last but not least, the current iteration of EDGEBOX is a single socket platform, and there are reasons for that, which really make the choice of AMD quite straightforward. We'll speak about them in a sec. And finally, we have so-called infinity guard technology. We have a hardware level encryption that allows you to safeguard both your data, your encryption keys, your application stack. So if we look at AMD today, at AMD EPYC processors today, we really were first to market with 7 nanometer technology, and that allows us to basically do two things. We can pack twice the number of cores in in existing thermal power envelopes, or we can actually reduce the power if we need to. So our CPU range is quite dynamic in a sense of having from 8 to 64 cores, while all the rest, like the amount of memory you address, the number of channels there, the amount of PCI Express lanes, things like boost frequencies, and all other tech like security, it's always staying the same. So the idea is that customers really choose between core count, frequencies, and cache, and the rest goes by default and available both in our single and dual socket infrastructure, which makes the choice much easier because we really are customer centric and we're trying to disrupt the industry with offering a much more performant and fully fledged from a feature stack product. And there are really two kinds of CPUs that you can opt for. If you, for example, the bulk of products that we have launched, second generation Rome CPUs, as its code name is Rome, we launched them last year, August, and they're about having 8, 12, 16, and 32, 48, and 64 cores. And basically, it's about VM density. It's about making sure that you have the best VM density and plus, things like value optimized infrastructure. If you have applications that are charged per core, or if you have applications that are single or low threaded, you might want to look at our 7FX2 series, which was launched this year in April. There are 8, 16, and 24 core CPUs that actually operate at a much higher frequency with a much larger cache. And they are really, we consider them, exceptional in terms of the single thread performance. So if customers want to get the best performance per invested license dollar, these are the 3 chips to go with. And so if you look at the different kinds of deployment, what you can, at the end, you can do is really either a software-defined deployment using low core count or higher VM density using 48 and 64 core CPUs. Let's try to progress to the next slide, please. Okay. Really, the idea, when I'm talking to partners and customers in Europe, what I see is that a lot of people still buy 2-socket systems because that's how it was historically. We see people assuming that the second CPU provides some CPU redundancy. While it's not true anymore, the second CPU will not provide you the redundancy and fault tolerance. We see people buying second CPU in order to attain various more expensive options that were provided and are provided with our competitor. Our segmentation is different. We want to make sure that even our single socket platform provides an abundant level of resources, both on memory pool and on PCI Express, on I/O. So you can connect a lot of drives and ports and cards directly because we have 128 PCI Express lanes. And so what it really gives you is the ability to start consolidating both sockets and servers. Our strategy going forward is to migrate people where possible to single socket from dual socket and from a 4-socket infrastructure to our dual socket platforms. What it provides you is smaller footprint servers, you know, a single socket also gives you 150 to 200 watt power savings, while you still can have up to 64 cores per socket, single socket, right? And also latencies go down because when your cores are located physically inside, or you know, just a single socket on one organic substrate, they talk to each other faster, and it's faster than any other dual socket x86 system. So it also makes sense, you know, from CapEx, because obviously the platforms just cost cheaper. There are fewer components to feed one socket instead of two. So yeah, if we move to the next slide, you'll see that at the end of the day, even compared to the dual socket Intel system, you can get more cores today to host more VMs, and it really depends on you know, customer policies, whether, you know, a blast radius of how many, you know, VMs are fine to fall in case there is a fault with the system. It's really up to them to control. But what we see really is that customers start to deploy more than 32 VMs per server, and we're really driving these customers forward to use, you know, 64 plus VMs unless there are some specific policies in place, or they need higher performance VMs, and then we switch them over to our high frequency pods. So the only case where we see, or a couple of cases where we see dual socket systems based on AMD EPYC, you know, as a viable solution, is when you need either higher bandwidth per core. So for instance, you can take a dual socket, I don't know, 32 core each server. So you have more memory channels to feed each and every core. And obviously, if you need a super huge memory footprint to host, you know, to hold all your data in memory for in-memory databases, obviously dual socket systems might be a better choice as well. Next slide, please. And so with that, you know, let me just quickly tell you that our second generation CPU really has a very high performance across a broad number of workloads, and this is like, we have partners and customers claiming these results, and they're available on our website. The key takeaway from this slide is that it has a balanced performance. Our EPYC second generation CPU can address your big data, your containers, your HPC environment, and quite a bit on the enterprise side. You know, Java is amazing in terms of the server Java to run your OLTP, for example. Things like software-defined storage, things like databases. So it's really an amazing feat of what our engineers were able to achieve. Next slide, please. So, and I see questions coming, we will address them at the end. The quick thing that I'm gonna say now is that in terms of the dynamic frequencies and thermal control, AMD is in a second generation, is an amazing process. We can boost the all cores to 3.2 gigahertz normally, unless there is not enough of power, or you don't keep your server in unprofessional environments. So it's really amazing how we do that, and if we have time, I'll address it in more detail. Hardware-based security is something I want to concentrate your attention to. This is our investment in future, and DIAWAY also has plans to together with Virtuoso to look into this technology more. What we essentially offer, we are first to market with full memory encryption, and we're talking physical DIMMs. But we as well can encrypt virtual machines inside this physical memory, which is already encrypted with a single encryption key. And so basically what we are trying to achieve is both making sure that whether you deploy it off-prem, even, you know, your edge embedded deployment somewhere where you have servers somewhere in a remote city unattended, or you have systems in you know, a co-location environment. We have technologies that allow us to provide better security and reinforce it, and it's all on a silicon level. And the best thing about our technology is that there is no application impact, either in terms of the need to recompile applications is pretty much transparent to the OS, or in terms of the performance hit, because our architecture is made in a way that the entire chipset is already on board under the heat spreader. And so we can tightly integrate our security technology to our memory controllers, to our North bridge. So there is virtually no performance hit. Next slide, please. And so what we offer is an AMD secure processor. It's actually an ARM8 microarchitecture. It's self-contained. It has its own operating system. And what it really does is providing functionality to our random generation engine to generate unique keys, self-contained, and to store them. And so these keys could be used for several different like it's in several different ways, let's put it this way. First and foremost, what it does, and next slide please, it's really enabling a hardware validated boot. And the idea is that there are management controllers with different servers, be it ODM or OEM servers. And so their management controllers can talk to the CPU to use AMD Secure Root of Trust technology, where you really confirm the way your authentic firmware as software is booting to control even things like whether the CPU is still the same as it was when the system was programmed, because each and every EPYC CPU has its unique serial number. And so basically we are, it's a round robin boot up session where you can protect your environment better. And there are cases in Western Hemisphere where insurance companies that deal with IT clients actually reduce the payments and amount of money to pay, whereas you have this, whenever you have this technology already, whenever the server is based on AMD EPYC second generation or first generation CPUs. The second technology is called secure memory encryption, and it's a single 128-bit encryption key that is issued to either protect the entire amount of DIMMs or just a certain memory region. And so it's enabled on a BIOS level. It's transparent to the OS. The maximum performance hit that you would see is probably about 2.5% if you run stream, try it. And what it does is really making sure that, for instance, if there is a qualified hacker who wants to do a cold boot attack to take the DIMM or NVDIMM and just read it in another system, and there are ways to do that by applying, for example, inert gas to freeze the data for 5-6 hours. So in our case, if the technology was enabled, the DIMM is going to have hashed encrypted data. So that's the second technology, and it really helps for off-prem uncontrollable premises and kind of deployments. And the third technology is addressing VMs. So it's called secure encrypted virtualization, and what it really does is providing up to 509 encryption keys to cryptographically insulate your virtual machines. And we have several kinds of technologies. I'm not going into details, but the iterations we have within this SEV is also allowing us to, like with the newer versions of it, to control how your hypervisor reacts and behaves. So we can prohibit hypervisor from actually reading into context of virtual machines. So there are various facets of what we can do. And this technology is actually supported today with KVM-based hypervisors. And VMware recently announced for the vSphere 7 is support as well. And we are in talks with Virtuoso to look into that more closely as well. It is a great way to buy today the system from the EDGEBOX system from DIAWAY and get this technology implemented as we go forward. Last but not least, also the largest cloud providers such as Google start to use this technology. Google recently announced confidential VMs on their N2D instances using exactly this technology. Next slide, please. And I have to wrap up. So yeah, if you look at all these side channel attacks, because we integrate our memory reads and writes with our security engine so tightly, and we designed our security stack early on when we were doing our microarchitecture reviews. So it's really not a bolt-on approach. Really thought into this for a number of years. And as a result, when you start comparing our number of vulnerabilities versus competitor, there is much less exposure. The surface of exposure is smaller. So there are some links available to check that out later on. Next slide, please. And so with that, let me really summarize. We have very high performance. And we also, and it's not only virtualized environments, though if we look into standard benchmarks, is both for SDS and HCI, we can provide quite an ability to host more VMs, more VM tiles, and better performance per VM. But it's also a TCO. It's better hardware acquisition costs if you use single socket AMD nodes, and it's better total cost of ownership. We have a calculator on our AMD.com website. If you just Google EPYC tools, you'll arrive to the page where you can play with different deployment scenarios using 1 and 2 socket systems and looking into different kind of virtualization infrastructure deployment scenarios to choose the preferred one, and see that we can actually drive anywhere from 15 to like 48% better TCO. And so we have this no compromise single socket agenda where we really suggest that the industry should take notice. And Gartner has actually stated before that they believe that by year 2021, probably about 80–81% of workloads will be perfectly addressable by a single socket platform because of the advancements in core density and performance per core. And last but not least, we have an amazing security stack, which is silicon level, which allows us to protect both physical memory and virtual machines. And with that, let me bring it to Vladimir, the product manager from Virtuoso. Vladimir, the stage is yours. Thank you.
Thank you very much. So the question is how to leverage all those amazing technologies for your business. And if your business is to provide cloud services in terms of private or public cloud, whatever, we have a solution for you, Virtuoso Hybrid Infrastructure. Why we started this solution actually? Because what we hear from our customers that they have at least 3 main pains. If a business currently is based on VMware, for example, obviously in some cases, not in all cases of course, but in some cases, to provide cloud based on this solution is very expensive for their customers, and their customers cannot afford it. Additional thing, if you build a cloud on such technologies, you need to combine a lot of different solutions together. You need to combine virtualization, storage or software-defined storage, cloud platform on top, and self-service billing, and so on. And this is becoming a very complex project. If you build your cloud offering based on open source technologies, in this case, I would say it's quite easy to start, because it's really easy to install KVM and OpenStack, for example. But it's really hard to maintain it, support it, and update it, and provide additional services. So in this case, you need a lot of investments. First of all, investments in your people, in your engineers. And the third thing, if your business is based on reselling hyperscalers, for example, in this case, you are in a very weak position where your customers finally can go to hyperscalers without you. And for all those pains, we have a solution, Virtuoso Hybrid Infrastructure, that allows you to build your own cloud, your cloud out of the box, and provide a lot of use cases on top of it. For example, based on hybrid infrastructure, you can build a private cloud for your customers if you are a system integrator, for example. So you can build an isolated private cloud. If you are a service provider, or if you are a managed service provider, in this case, you can build a public cloud based on our technology. And our technology already includes multi-tenancy with self-service portal, so you can install it and provide cloud to your customer. It includes virtual networking. It includes services like Kubernetes as a service, load balancing as a service. So you can provide not just infrastructure as a service to your customer, but you can add more and highly valuable services. And our solution supports multiple billing models, so you can sell your cloud using pay-as-you-go model, or you can sell predefined resources. It's up to you. Our solution already integrated with multiple billing platforms, so you can select the best billing platform for you according to your needs. And we have, I would say, fully pay-as-you-go licensing. So you pay to us only for resources you can sell, not more. And I will show it on the next slide. But our solution is based on no, please please switch back. Please switch back. Yeah, thank you. I will show it on the next slide. But our solution is based on OpenStack. So it provides the standard OpenStack API. So integration with our solution is really easy. As for the managed Kubernetes service, our managed Kubernetes has an integration with our load balancers and storage solution. So your customers can provide load balancers and persistent volumes for their applications right from the Kubernetes without any additional integration. And of course, if we talk about such modern use cases as backend for applications, for web and mobile applications, S3 storage is mandatory, so we also provide it. So you also have it in our solution by default. And if you would like to provide such services like workspace as a service, it's also included in our solution. So you can do all the services based on the single hybrid infrastructure. So time for the next slide. Thank you. So technically, our solution is based on Virtuoso hypervisor. This is, I would say, KVM on steroids. So it's an advanced version of KVM. We also have our own software-defined storage, Virtuoso storage. On top of that, we have OpenStack with multiple services. And we have administrative panel for you to manage this cloud. And we have integrated self-service interface for your customers. And as I said previously, we support standard OpenStack API. So all solutions which already work with OpenStack will also work with our solution by default. And of course, we have integrated monitoring tools like Prometheus and Grafana to visualize it. So solution includes all components you need to build your cloud. You can just install it and tomorrow provide services to your customer. Next slide, please. So as I said, we have self-service interface. So it includes all our services, and with every release, we add more services to it. So it's ready to use Cloud Portal. Next, please. And as we position our solution as a cloud out of the box, the integration with hardware solution is very important for us. And here we have very good integration with DIAWAY appliances based on AMD. And based on those appliances, we can guarantee you the predicted performance. So if you come to us and ask us you would like to run few thousands virtual machines and you would like to have a particular amount IOPS for your customers, we can give you the exact configuration you need. So you're not on your own here. We can help you to buy the most cost-effective configuration you need for your customers. Because we tested, we know our configurations, we know our software and hardware we are working on. Please, next. This is also just an example of our performance test. So you see that in some configurations, we provide up to 1 million IOPS per appliance, per just 4 nodes appliance. And for virtual machines, you also can have up to 100,000 IOPS. That is amazing for cloud workloads. But what if you don't want to invest in your own cloud, but you want to sell cloud services and sell your expertise, your additional services on top of it? In this case, we also have a solution for you, Virtuoso Hybrid Cloud. Hybrid Cloud is a cloud from Virtuoso only for service providers. So we are not going to sell it to end users, but you as a service provider or managed service provider, you can come to us and buy resources from our cloud. So the benefit of this solution are simple. So actually, what options do you have if you want to resell cloud services, if you want to offer a cloud to your customers? You can build your own cloud, right? Your on-prem cloud, but in this case, you need significant investments in hardware, in software, and of course in engineers. And if you're going to build your cloud based on open source technologies, you need to invest in very expensive engineers. But if you want to resell clouds from AWS, Azure, and so on, in this case, yes, you don't have any. Dmitry, please. Of course, you don't need to invest in infrastructure, but in this case, you have to compete with all other service providers using this approach. You have very low margin. You don't have any flexibility because you cannot, if you are a medium service provider, you cannot negotiate with Amazon or Azure. It's just not impossible. Just possible. Finally, customers can go directly to Azure or AWS without you. Next, please. So our hybrid cloud, Virtuoso Hybrid Cloud, it includes all our technologies already pre-integrated together, managed by us, providing all possible services, and with clear and predictable guarantees and SLA for you. And for you, this means that you don't have any investments, right? You still pay only for resources you consume from our cloud. No any commitments, no any repayments. And you can run your business in multiple regions where we have our cloud. You can, if you have your own on-prem cloud based on our technology also, you can build a hybrid cloud solution and move workloads between your on-prem cloud and our public cloud. And you will have new features, new options for your cloud every quarter with every hour release without any additional investments. And we do not compete with you because we provide our cloud only for service providers. Next, please. So how it works? So we provide you all infrastructure, actually the same cloud offering as you get from other public clouds, right? With support, we can also give you a marketplace or billing or metering, or you can bring your own billing solution if you want. It's also possible. In this case, we will give you only an infrastructure. And you can sell additional value-added services on top of this cloud. Of course, you need to onboard your customers, but we have a professional services team who can help you with customer onboarding. So it's not up to you, we can help you. And of course, you provide first and the second line of support for your services. So based on this solution, you can get your cloud services just tomorrow without additional investments and in multiple regions and without any competition with public clouds. So next, please. Dima?
I guess this one is mine. Okay, what we've touched a few times previously, the approach infrastructure design, we call it Techonomics. And as we are slightly out of time, I would like to skip the theory slide and proceed with a practical example of Techonomics. So when designing solutions, and this is what we had in case of EDGEBOX, one has to deal with choices. And our first customer who signed up for the solution had a project with around 20 sites to deploy. And the project could only be accepted if complied with a few very strict requirements. Target cost per deployment, including licensing cost, completeness of the solution, hardware, software, networking, computational power to run full-fledged HCI in exactly 5 servers. So we shuffled with multiple designs because there was an additional constraint on useful storage capacity, the solution we had to provide. And eventually we end up with a TCO spreadsheet that proved technically and financially the choice of AMD CPUs. So the savings are visible, and at a scale, they are quite significant. It proves that a good design not only ensures the performance is up to expectation, it also makes a chief financial officer happy, which is a big thing. And to design a right-sized EDGEBOX for you, you can book a meeting with DIAWAY experts and get full insight and actionable items to move ahead with this solution. The process we follow is simple and ensures the insights into infrastructure designs are unlocked quickly. Okay, now it's time for a Q&A. We have some questions. Let's address them.
So there was a question on VROC and if we have any kind of technology that is close to Intel's VROC. The answer is no, we do not plan to have VROC soft rate functionality. We do have things for surprise removal and port insertion, but at the same time, we do think that as a high performance platform, we'd like the customers to have a choice of different HBAs and hardware rate controllers to take advantage of all technologies. And given the advent of NVMEs, yeah, we do believe that, going for a specific solution would be better. We still drive the costs down significantly. And so, as a soft rate solution, yes, you can opt for that. But if you look from the overall acquisition cost perspective, I mean, we are in a favorable position anyway. So yeah, with AMD, we suggest to go forward and choose you know, a specific adapter to implement RAID subsystem.
Based on our experience, I mean, DIAWAY as a global integrator, we see that NVMe is good for software-defined storages to unlock native NVMe performance. While there are some bottlenecks using traditional RAID controllers, so it makes sense to use software-defined storage or software RAID with the NVMe drive specifically. So
there's a question: at which regions, countries is Virtuoso Cloud available?
So the first region of Virtuoso Hybrid Cloud will be in Germany. But next year, we are going to add more regions in United States and in Asia.
Actually, going to the VROC, as there are no questions, new questions so far. Let me just also say this: with AMD EPYC platform, whether it's a single socket or dual socket, you have 128 PCI Express lanes for direct attachment of drives. And basically, what we see today is up to 24 NVMEs directly connected on certain platforms. And half of the PCI Express lanes actually can be consumed for CPU to CPU communication, and half go into the I/O. That's why there is it's the same lane count for both single and dual socket platforms, and that's where you actually get the advantage with AMD. You just get better latency without the need to use any switches, and we just think that it's a better way forward instead of just having a software RAID functionality. Thank you.
Let me check other questions as well. So I don't know if it's already addressed in text or not. There was some concerns regarding AMD CPUs based on like very ancient myths about overheating and so on. So Alexei, could you please address that shortly?
Yeah, I mean, I wrote a text, a long text, so sorry for that, but yeah, we don't have any issues whatsoever with that. The current technology does not have any hard-coded frequency steps. It's dynamic. We have P and C states, and combination of them allows us to drive CPU up and down by 25 megahertz steps, or in steps. For that matter, and basically what we are able to achieve is ramp the clocks up whenever the CPU counters tell us that there is more bandwidth needed from the application side. For as long as you don't have any vector instructions, any kind of high performance LIMPAC, the CPUs should work at above 3 gigahertz level, normally 3.2 gigahertz, sometimes 3.3, depends on the model. And we are very careful with actually claiming that, because sometimes there are users just who would just say, look, we have 50 megahertz, you know, smaller frequency, and so we don't want any legal cases. But for you, the takeaway is that really the CPUs will be clockable up and down, and it's going to be a very fine granular steps that it's going up and down with. This is for as long as you have enough of power provided by your power supplies, and the temperature is actually in line, like 22 to 26 centigrade ambient. And last but not least, because the T case is 95 centigrades, we really keep, even during the burn-in test, we really keep the frequencies up. That's how, you know, that's one of the reasons we actually drive the performance up. That's why we provide leadership in so many workloads and applications today.
And actually, based on like a real case with the EDGEBOX, we see that, for example, for the provided example, we can see that the TDP of two Xeon CPUs is actually higher than the TDP for single socket CPU AMD. So we expect some savings on power for such deployments. So we at least 20% based on our calculation we can save just using a AMD EPYC CPU single socket servers versus dual socket Xeon that actually had slightly slower frequency.
Well, let me just wrap it up by saying, look at our Renoir laptop chips that are in like 15-watt thermal envelope, and all the great news that are coming on different thin and light platforms that are coming out today, and providing both great performance and competitive battery times of above 8, 10, 12 hours. So that's the answer.
Okay, so thank you all for attending the webinar. I guess time's up. We will address additional questions via email, and we will pick up top 3 interesting questions to send you the gifts as agreed. Thank you for questions.
Thank you all and have a great day.
Have a great day.
Thank you all very much. Thank you.
Bye-bye.
Bye.